The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to go on to section 5.5. But before we do that, I had one request. So I will take a look at that. This is from section 5.4, number 15. The directions say, find the degree of the polynomial. And we have 16ab to the 7th minus 18a squared b. Well, to find the degree of the polynomial, we need to first find the degree of each separate term. Then we go back and whichever term has the highest degree is the same as the degree of the polynomial. The thing we have to remember is that when there's no exponent, there's an implied 1. Okay, so the degree of the first term would be 8th degree. The degree of the second term would be 3rd degree. So the 8th degree term is the highest power. So the degree of the polynomial is 8, or yeah, just 8th degree. Okay, any questions about that? All right, then we will go on to the next section, 5.5. Back in, I think actually chapter 1, it talked about the idea of combining like terms. So if we have something like 2x plus 3y plus 4x minus 6y, and we want to combine like terms, we would take the 2x plus 4x and get 6x, the 3y minus 6y and get minus 3y, and thus simplifying the expression by combining like terms. Well, what we're going to be doing today is adding and subtracting polynomials, which ultimately will be combining like terms. Let's say, for instance, we had the following: 2x plus 7 plus 4x minus 3. So we are, in fact, adding two binomials. Now, when there's nothing in front of a set of parentheses, it's as if though there's an implied 1. Same thing here. But taking 1 times what's inside, basically you would get what's inside, but without the grouping symbol. Or grouping symbols, I should say. So our first step would be to remove the parentheses, because we don't want to try and combine like terms from 2 separate parentheses. We need to get rid of the grouping symbols first. Then we can come back and say, well, this is 6x plus 4. Any questions about that example? All right. Let's see here. Let's say we have this 8t squared plus 4t squared. To simplify this, we would do what? We would combine like terms. 8 of them plus 4 of them is 12 of them being t squared, right? So we're just combining like terms. If we have 17y squared minus 22y minus y squared, even though all 3 terms contain the same variable, they're not the same power of the variable. So these two are like terms, but they're not alike with the minus 22y. 17y squared minus 1y squared is 16y squared, and then minus 22y. Again, don't forget there's an implied 1. So minus y squared is like minus 1y squared. Okay, let's see here. This says 1/5 x squared minus 3/8 x plus 2/3 x squared plus 1/5 fourth x. Here, combining like terms, those go together and those go together. The problem with these and with those is they don't have common denominators. So 1/5 x squared plus 2/3 x squared. The least common denominator of 5 and 3 would be 15. So 1/5 multiplied by 3/3 becomes 3/15 x squared. 2/3 multiplied by 5/5 becomes 10/15 x squared. Now we can add them because they have a common denominator. 3/15 plus 10/15 is 13/15 x squared. Okay, now continuing on, we have minus 3/8 x plus 1/4 x. Here the common denominator, or the least common, I should say, denominator of 8 and 4 is 8. If it ain't broke, don't fix it. If it is broke, fix it. So we're going to take 1/4 and multiply it by 2/2 to get 2/8. Minus 3/8 x plus 2/8 x would be minus 1/8 x. And so that is our final answer with combining like terms. Okay, any questions there? All right, now let's say we have the following polynomials. 3q squared minus 5q plus 7 plus the quantity 2q squared plus q minus 12. Again, if there's nothing in front of the set of parentheses, like here, or just a plus sign, like there, it's as if that we have one of the group. And distributing one of the group, we would basically just get rid of the parentheses. Okay, so that's the first step. Then combining like terms, 3q squared plus 2q squared is 5q squared. Minus 5q plus 1q is minus 4q. I keep wanting to make a G. Instead, it just looks like a mess. Let's see. Oh, that's much better. And then plus 7 minus 12 would be minus 5. Now notice, not only did I combine the like terms from the two polynomials, but I wrote them in descending powers, which is a form of standard form. Okay, let's see here. We have another lovely example with fractions. 1/16 r to the 6th power plus 1/2 r cubed minus 11/12 plus the quantity 9/16 r to the 6th power plus 9/4 r cubed plus 1/12. So to get rid of the grouping symbol, again, if there's nothing in front of it or a plus sign in front of it, we can just rewrite it without the grouping symbol. Basically, we're distributing 1. So then let's see here, 9/16 r to the 6th, 9/4 r cubed plus 1/12. Combining like terms, 1/16 r to the 6th plus 9/16 r to the 6th would be 10/16 r to the 6th, which would reduce down to 5/8 r to the 6th power. Okay. 1/2 r cubed plus 9/4 r cubed. Let's see, 1/2. Let's get rid of this here. Need more room there. Okay, so 1/2 r cubed plus 9/4 r cubed. The common denominator there would be 4. So I'd take 1/2 and multiply it by 2/2, giving me 2/4 r cubed. So I've got what, 5/8 r to the 6th plus 11/4 r cubed, right? Now, recall, let's see here. Hang on a second. Yes. Recall that in WebAssign, we don't want to use a mixed number. So if this problem was in WebAssign, we would use 11/4 r cubed, not what, 2 3/4. Okay, so be very careful with that, just a reminder. And then finally, our constant terms, minus 11/12 plus 1/12 would be what? Minus 10/12, which is minus 5/6. So there is the final answer for that problem. Any questions there? All right, let's take a look at some decimals. 0.3p plus 2.1q plus the quantity 0.4p minus 3q. So again, nothing in front or a plus sign in front of parentheses. We can just recopy it without the parentheses. Then combining like terms, 0.3p plus 0.4p would be 0.7p. 2.1q minus 3q. We've got 2.1 minus 3. Remember what you do when you're subtracting a larger number from a smaller number, okay? So let's see here. We could change this to addition of the opposite. Now we're adding two numbers with different signs. We subtract the smaller absolute value from the larger absolute value, but then we attach the sign of the number with the largest absolute value. Oops, let's try that again. I didn't write that. Okay, so this would be negative. Now, of course, if you're using a calculator, 2.1 minus 3, you get minus 0.9 without all this rigmarole, but just a reminder of how that process works. Oh, what have I forgotten? This is q, right? Yeah, 2.1q minus 3q. Okay. Now, this is where things get a little more interesting. Let's see here. Let's look at using the vertical form to add polynomials as opposed to writing them all out horizontally. Let's see, I've got 3x squared plus 4x plus 5, and then 2x squared minus 3x plus 6. And the directions say, again, use vertical form to add the polynomials. So this would be 11, and this would be what? X and 5x squared. Okay, any questions there? All right, how about this one? Negative 2c squared minus 3c minus 5. Add to that 14c squared minus 1. So we're going to add these up. Well, negative 5 plus negative 1 is negative 6. And then we've got what? Minus 3c minus 2c squared plus 14c squared is 12c squared. I don't know about you, but I prefer adding them or subtracting them horizontally. It just seems a little more awkward doing it this way, even though with just basic numbers, arithmetic, we do add them up vertically, don't we? But we just kind of have to get used to that. All right, this says subtract the polynomials. So I have 3a squared minus 2a plus 4 minus the quantity a squared minus 3a plus 7. Well, let's come back to this problem in a minute. Let's say I've got, what? 4a minus 2a. Again, going back to arithmetic, in fact, wait, hang on. Let's make this a bigger number, okay? We've learned that you can change subtraction to addition of the opposite, basically doing that. right? So you change subtraction to addition, and then you take the opposite of the number inside. So then again, we get negative 4a. But what if we have something like this? A negative sign outside of 3x squared minus 2x plus 7, okay? And I want to change, what a mess. I want to change this to addition of the opposite. So the subtraction changes to addition, but then I have to change the sign of each term inside the parentheses. So this becomes a plus, this is a minus, a plus, and a minus. So again, distributing a subtraction sign, change subtraction to addition of the opposite, okay? And that changes the sign of everything inside. Another way to look at it is this. You're just distributing the negatives, so negative 3x plus 2, negative 3x squared plus 2x minus 7. Okay, it's like just taking negative 1 times what's inside. Okay, now let's go back to this problem. With nothing in front, I just rewrite it. It's as if though there's an implied 1 out there that we're distributing. But now I've got a subtraction sign. I'm going to change that to addition of the opposite. So this becomes a minus, this becomes a plus, and this becomes a minus. Okay, so now I'm adding. So I've got what? Minus a squared plus 3a minus 7. Any questions about what just happened there? So now combining like terms, 2a squared plus 1a minus 3, and there's the final answer. Adding polynomials is pretty simple. Subtracting polynomials, you've got to be careful that you distribute that subtraction sign correctly. Okay, let's see here. All right. Negative 4h cubed plus 5h squared plus 15 minus the quantity h cubed minus 15. So I'm going to get negative 4h cubed plus 5h squared plus 15, and then minus h cubed plus 15. Be okay with that? Any questions there? All right, coming back and combining like terms, negative 4h cubed minus 1 more h cubed is negative 5h cubed. And then I've got what? Plus 5h squared and then plus 30. Okay, let's see here. Let's do this. Just there's the final answer. This one, let's see, we've got 5/6 q to the 9th power minus 4/5 q to the 8th power, and then minus the quantity 1/4 q to the 9th plus 3/8 q to the 8th. Okay, so first of all, getting rid of those grouping symbols, I can just get rid of the first grouping symbol since there's nothing in front of it, or it implied 1 times it. Okay, now we're distributing the subtraction. We're going to get minus 1/4 q to the 9th minus 3/8 q to the 8th. Okay, so in effect, I'm changing it to addition of the opposite and adding it up, but just distributing the subtraction sign. Any questions there? Okay, these are like terms. Let's put them next to each other. And these are like terms. Now, oops, wrong color there. Least common denominator of 6 and 4 is 12. So we get so many 12ths minus so many 12ths. 5, 6, I'm going to multiply by 2 over 2 to get 10 12ths. 1/4, I'm going to multiply by 3 over 3 to get 3 12ths. 10 12ths minus 3 12ths is 7 12ths, q to the 9th power. Okay. So then moving on, the least common denominator of 5 and 8 would be what? 40. So I'm going to have minus so many 40ths q to the 8th minus so many 40ths q to the 8th. 4/5 I'm going to multiply by 8 eighths to get 32 40ths. 3 eighths I'm going to multiply by 5/5 to get 15 40ths. Minus 32 40ths minus 15 more 40ths would be minus 47 40ths q to the 8th power. And there we have that situation. Okay, let's see. Now, this says subtract 2x squared minus 2x plus 3 from 3x squared plus 4x plus 5. I'm going to come back to that one again in a minute as well. Let's say I had subtract a from b. Would you write a minus b or b minus a? Well, you're subtracting a from b, so that would look like that, b minus a. Okay. Now, it says subtract this from that. So I'm going to start with that. I've got 3x squared plus 4x plus 5 minus 2x squared minus 2x plus 3. But there's a problem here. There's something, well, of course there's a problem. They're all problems. But it says subtract that. So I need to subtract that whole quantity and then ultimately distribute that subtraction sign. Now, whether I put parentheses around the first one or not isn't going to matter in this case because there's no sign out in front of it, okay? But I've got to make sure I group that whole thing because I'm subtracting it. So then I get 3x squared plus 4x plus 5 minus 2x squared plus 2x minus 3. Combining like terms, 3x squared minus 2x squared is 1x squared, plus 4x plus 2x is plus 6x, and plus 5 minus 3 is plus 2. So be careful. It's like addition, you can almost get away with anything, but subtraction, you got to be really careful, really careful. Okay, now, let's take a look at this. Let's see here. There's one. Here. 7m to the 5th power plus m cubed plus 9m squared minus m. And then it has 8m to the 5th minus 2m cubed plus m squared plus m. And then there's a subtraction sign. So it basically is saying subtract the bottom polynomial from the top polynomial. Now, here again, it just seems less awkward to do it horizontally, rather than vertically. But there's something coming later in this chapter where we're going to have to do this process. So this is kind of introducing the idea. What we're going to do, we're subtracting the polynomial in parentheses from what's up above. But how we're going to do this is we're going to change subtraction to addition of the opposite. So that becomes a minus, a plus, a minus, and a minus. Now I'm adding two polynomials, so I can ignore the parentheses, right? I can drop the parentheses. So I've got, let's see, what is this? 7m to the fifth plus negative 8m to the fifth is negative 1m to the fifth. Okay. M cubed plus 2m cubed is plus 3m cubed. 9m squared plus negative 1m squared, excuse me, is plus 8m squared. And negative m plus negative m is negative 2m. How are we doing? You okay with that? Again, that's a little bit tricky. All right. Let's see here. How are we doing there? Let's look at some pictures, some drawings here. Okay, so we've got two airplanes. I'm going to make a feeble attempt at drawing an airplane. Let's see here. I know I'm not an artist by any means, maybe a con artist. And then let's see, we've got a smaller plane. Looks more like a sick whale than an airplane. Okay, anyway, there's our airplanes. So we've got this information. It says that from here to there is 9x minus 15 feet. And from here to here is 2x plus 3 feet. Okay? So this is to line up with that, and this is to line up with that, and then this is to line up with the back of it. It says, find the polynomial that represents the length of the larger jet. So what would you do? You'd add these two polynomials, right? Okay. So we've got 9x minus 15 plus 2x plus 3, which is 9x minus 15 plus 2x plus 3, which is 11x minus 12. But I've left them off. It's important to put them out at the end. That is feet. Now, in WebAssign, sometimes it has a box and it has the units outside of it. Other times you have to put the units in. So be careful, pay attention to the units. Okay. All right. I think that's all I've got for you today. So I will be back this afternoon at 1:15. I'm going to go ahead and stop the recording.